Okie dokie, here we go. This is week 1, part 2, where we are remembering and practicing and maybe learning some new stuff about factoring. So, here are our formulas. They're just written for you. So, this is called difference of perfect squares. And you've seen these kinds of things where this can be written as a plus b quantity squared. This could be written as a. So, we could write this as a plus b quantity squared, and we could write this as a minus b quantity squared. And the stuff that may be new but maybe not is where we have these. So we have something to the third minus something to the third. So difference of perfect cubes or sum of perfect cubes. And so they can be factored in this way. So let's take a look, work through some examples. So number 1 looks like difference of perfect squares, where we recognize this is 2x times 2x, and this is 5 times 5. You can always check by multiplying out, right? So we're going to FOIL. So let's see, our firsts give us, so first would be like this, and we have 4x squared. Outers would give us plus 10x. Inners, and we won't be doing this for all of them, and then lasts. But just so you know, do you see how these cancel, giving us this? Okay, so if you're confused, you can always multiply out just to verify that your answer is correct. So let's take a look at number 2. We have a trinomial, and if there is something common to all of the terms, you factor that out first, always. So there's a 2 common to each of these, and there's an x, and not just an x, but an x squared. So I factor that out, and leaves us with, let's see if this is right. Made a couple mistakes in the last video, so I'm double checking, so this looks good. And from here I thought, oh well, we'll set up 2 parentheses, right, x, and so 2 numbers. These have to multiply to 7, but add up to 2x, and it wasn't working. So this gets scratched, and this is our final answer. Number 3. So this question's thrown in there to get you thinking about factoring by grouping. Okay, this and this have in common an x minus 5. So it's like x minus 5 gets pulled out of the parentheses, leaving you with just x plus 7. So this right here would be your answer. And we could write this as x minus 5 times x plus 7. The order of the parentheses can always be changed, and those will be both okay. Number 4. So let's see, do we have something common to all of them? Definitely not, but this looks like factor by grouping. So I'm going to write that just so you see it and hear it. Factor by grouping. And the way that the problems are set up, a lot of the time you just group these two together and group these two together, but it's not always going to be that way. What you're looking for is, if you group 2 of the terms together and 2 of the other terms together and factor, do you see what's going on here, where from the first 2 we can factor out an x squared, and from these we can factor out minus 3, and notice how what we have in parentheses is the same. So it's just like the previous question, where 2x plus 1 is factored out, leaving us with x squared minus 3 as our other factor. And what the common question here that students say is, what happened to the other 2x plus 1? They're looking at the answer and they think it's wrong. What happened to the other 2x plus 1? Well, this is factoring, so because it's common to both, right, it gets pulled out of the parentheses. What I recommend is that you go ahead and distribute. So if you're confused, you're like, where's the other 2x plus 1? Go ahead and multiply, okay? X squared times this minus 3 times this, and you'll see that we end up with that. Okay, so multiply it out, you'll get this, and then you will be a believer. Factor by grouping, same thing here. Grouping these 2 together, we can factor out an x to the 4th, and grouping these 2 together, we can't factor out anything, so we put a 1 out front. Sometimes that's a little confusing. So x plus 1 is the thing that is common to both, and that ends up here. And what we have left over is x to the fourth plus 1 in our second set of parentheses. Alright, factor by grouping. Let's take a look at the next page. Next page. Oh, who's in charge? Please factor. Alright, so these were fun when we first learned them, the basic trinomials, right? You set up two parentheses and you're just sort of doing FOIL backwards. I don't think I'm going to go through all that, but this ends up working, right? I always check the inners and outers, so we have minus x minus 5x, giving us a total of minus 6x. Okay, so it works, because you look at the first term and you look at the last term to figure out what goes here for the first terms and what goes there for the last terms. It gets a little more involved when we have a situation where there's a coefficient. So the first terms, we know from the 3x squared, we know we need a 3x and an x, and then I put these question marks here. This is where students go, hey, I don't know what to do, right? We're trying to figure out this number. So it involves some guessing and checking, which is actually really good for you because it's going to help develop your number sense. If you want to use the magic triangle method or whatever, feel free, but I don't think it's worth teaching or memorizing, you know, just think it through. So anyway, looks like two numbers that are going to multiply to a positive 5, and if we use a negative 1 and negative 3, so I was saying, we have 15 and we have 1, giving us the 16. So minus 1 minus 15x, both of those combine to a negative 16x, and there we go. So factoring never goes away. X squared minus 4y squared, so this looks like the difference of perfect squares, x times x and 2y times 2y. So notice how the middle terms cancel out. Our firsts give us x squared, our lasts give us a minus 4y squared. And again, if you're looking at the factoring stuff and you're confused, multiply it out. Multiply it out. You don't have to for the answer, but in order to figure out how to go from here to here, going from here to here helps you get a feel for how it works. I know that, you know, I've been teaching math a long time, and factoring is not an easy thing for students a lot of the time. So multiplying it out, even though it involves a lot of work, will help you come to an understanding. So again, we have a difference of perfect squares where this first term is x plus 3 squared, and the second term is 2 squared. So we have first term minus 2, first term plus 2, right? If we were to multiply out, the middle terms would cancel. And our first terms would give us this, and our last terms would give us this. So notice how I put brackets here because we can do a little more simplifying. This is x plus 5. And this, x plus 3 minus 2 is x plus 1. So it ends up looking like that. Cool. Where are we? Number 10. Alright, so here we get to use the sum or difference of perfect cubes. On the notes, this was a squared, which was a mistake. Maybe I changed that. So it looks like this. This is our question, and so you're recognizing that the first term is 2x all to the third. And the second term is 3y all to the third. It's the sum of perfect cubes, meaning something to the third and something to the third. That's what we have to recognize it as. So if you're looking at the formula on the previous page, it means this thing here is our a, and this thing here, it's actually the 2x, and this thing here is our b. So we have a plus b and a squared minus ab plus b squared. Common mistake, students forget that the 2 is actually squared, right? So we get 4x squared, and they forget that the 3 is actually squared, so we end up with 9y squared. And I know you get to this part and you think, ooh, this is probably factorable, but it never is. So I may take a look at it, maybe it will be, but Probably not. So there you go. This is the factored form. It would be a fun exercise, super fun exercise to go ahead and distribute, and then combine all the like terms, and behold that you end up with that. Whew! Man, that would be fun. Number 11, similarly, so this should have been an x to the third. Shame on whoever wrote that. But we have to recognize that this is something to the third power. 5x to the third power. 5 to the third is 125. And this is something to the third power. That's 2 to the third power. So here we're subtracting. Notice the difference in the equations. I know these equations look crazy, but they're actually not that hard to memorize, where there's one minus sign in the entire equation. One minus sign in the entire equation. And if it's a plus, it starts with a plus. If it's a minus, it starts with a minus. So anyway, that's how I remember them. So 5x minus 2, and then 5x squared plus 5x times 2 plus 2 squared. And then we square it all out, and voila. There we go. Okay, so that was fun. Factoring. Next up will be the advanced factoring. I can't wait